So the purpose of this lesson is to teach you how to do z-scores. Now, I'm already assuming that you know that when you're working with populations, you only use mu and standard deviation, and I'm also assuming that you know what a standard deviation is. So that being said, the purpose of a z-score is to convert a set of raw scores and figure out how many standard deviations away from the mean of those scores a certain score, which would be x, is. To figure that out, there's an equation, and it is z is equal to x, the number that you are looking for specifically, minus mu, which is the mean, over the standard deviation. The example that I'm going to be using is a set of test scores for a final exam. Let's say that the mean of the test scores is 70, which I put already up here as the mean, and standard deviation is 15, which means that 15 points away from the mean would fall at 85, and then 100, and then going backwards 55, and then 40. For the sake of this test, the lowest person who scored a 40, and the highest score was a 100. So the first question that I'm going to be going over is how many standard deviations away from the mean is a 90? Let's say that I scored the 90. So x is equal to 90, and using the equation right there, I get to fill in the blanks. So 90 minus mu, which is 70, over standard deviation, which is 15, is equal to set 20 over 15, which roughly goes to 1.33. We don't need to use the z-score table for this. 1.333 is the standard deviations away from the mean. Since this right here, between 85 and 70, is one standard deviation away from the mean, my score of 90 would fall between the 85 and the 100, leaning more closely towards 85 for obvious reasons. It's only 5 away. The second question that I'm going to be going over is what percentage of the people scored below the score of 85? We need the z-score table in the back of the textbook for this. But since the camera can't pick it up, I'm just going to tell you how it goes. Whoops, it fell. So in this case, x is equal to 85. And our z-score is going to go like this. 85 minus 70 over 15, which is a standard deviation, is equal to 15 over 15, which is equal to 1. It's one standard deviation away from the mean, but since we're trying to figure out how many people scored below 85, we're literally trying to figure out how many people scored through all of this. So we have to go to our table and find 1 in the z-score. I'm just gonna show you right here. And 1 is right over here, and since we're trying to find a proportion in the tail, that would be, proportion of the body. That would be 0.8413, and move the decimal place over 2 points to make it a percentage. So 84.13% of the students scored below the score of 85, which makes sense because that's the majority of the deviation of the distribution. The third question is what percentage of the people scored between the mean, which was 70, and my grade, which is 90. So that's the same thing. You use the z-score of 70, 90. Damn it, can we cut that? No? All right, so we use the mean score of 90, and we have to subtract 70 from it over 15, and we end up getting 20 over 15, which is equal to 1.33. That's the same as this, but this time we're trying to find how many people scored between 70 and my score of 90, so all of this over here. And that requires going into the chart, finding the proportion of people between mean and the z-score, and that is equal to 0.4082. When you get 4082, move it over 2 decimal places, you get 40.82% of the people fell between the mean score of 70 and 90. And that's pretty much the basic questions that you'll get asked related to z-scores. Thank you.